Hello students. All right, today we are going to work out some linked genes problems. So let's do that now. And again, this is 10.2, inheritance. So let's pretend that I am crossing two linked genes as such. So I'm making up the alleles here. I'm calling them AB dominant, AB recessive. So let's say that I'm crossing two heterozygous linked genes as such. Okay, so how do I set up a Punnett square like this? So remember that the linked gene Punnett squares could potentially just look like a monohybrid cross, where you keep the genes together. Right, you keep the two alleles, that are within that same chromosome, or these two linked gene alleles. You keep them together as such, and then you cross them, right, like this. So notice that this is different from what you've been doing in the past. And this is what you could potentially get. Now, we know that these are the parental genotypes, big A, big B, little a, little b. So then that means that most of my offspring are going to look like the parents. And I guess I'll keep that in red. And then the parents are this guy and this guy, right? So most of my offspring are going to look like my parents, okay? And then notice who the recombinants are. This is a recombinant. This is a recombinant. So few are going to look different than the parents. Okay, so it's not, notice that here it's not a 25%, 50%, 25% ratio, because this is not following the law of independent assortment. So I don't know how much, right? But I know that the majority of them are going to look like the parents. If recombination is possible, and that's only if these genes happen to be far apart in the chromosome, there is a few possibilities, right, for recombinants to look like this. Okay? So most like the parents, few like the recombinants. So this is how you would work out a linked problem. All right, let's do another one. So what if I give you just a question that looks like this? Let's say I'm crossing these two genes here. And big B stands for gray body fruit fly. VG stands for normal wings. B plus stands for black bodies, and VG plus stands for vestigial wings, or just the shorter wings, right? And I'm telling you that these are linked genes, and you can see from the notation, right, that they are linked. So what if I ask you to tell me how many possible gametes you could get from this type of parent? Okay, so remember that one chromosome is going to look like this, and another chromosome is going to look like this. Okay, so this is chromosome 1, let's say, and this is chromosome 2. And let's say there's no crossing over. Okay. So in this particular example, there's no crossing over, because let's pretend that the genes are very close, right? So there's no recombination, there's no crossing over. So what potential gametes could we end up with? Well, we are going to end up with gametes that look like this, and gametes that look like this. Right? So two potential gametes, or two possible gametes, just like the parents. All right. But now, let me just draw here so you can see a contrast. Now, let's say that crossing over happens because the genes happen to be far from each other. So again, I have the same parental phenotype or genotype here. So how many potential gametes could there be if there is crossing over or recombination? Well, in this particular case, of course, I always have most of the probability like the parents, right? Or most gametes are going to be like the parents, like so. And actually, I forgot to include a little plus here. So I'm going to get one potential gamete that looks like this, one potential gamete that looks like this, but also don't forget that you can get recombinant gametes too, right? One that looks like this, so that's another possibility, and then one that looks like this, so that's another possibility, okay? So you can end up with 4 possible gametes if you allow for recombination or crossing over, because the let's say the genes are far apart from each other. Okay, so you might have questions on a test that ask you like something like this, right? What are the possible gametes of a particular genotype if the genes are linked and there is no crossing over because the genes are close together? Or what are the potential gametes from a genotype that looks like this if there's crossing over because the genes happen to be far away from each other and there is recombination? Okay, so it's a difference on the type of questions that they might ask you. All right, let's work out another problem. So in this particular problem, let's make a key first. So let's say that I'm crossing a couple fruit flies here. So ebony or black bodies stands for the letter E. Brown body stands for the letter E+. And they can give you any notation that they want. Scarlet eyes on that fly are denoted by this. And red eyes on that fly is denoted by this. ST+. And let's see. Let's define what the wild type is. Now remember that the wild type is usually the dominant genotype. And in this particular case, it's the normal type of fly. So in this particular case, if the fly has brown body and red eyes, then it's the wild type. Okay, so that means that you should know what the genotype for brown red eyes looks like. It would be something like this. This is brown red eyes. Okay. So what if you do a cross between a homozygous ebony body, scarlet eyes, with a wild type? Okay. So how would you do a Punnett square like this? Well, first you have to first look at the possible gametes. So this parent can probably just give you one particular gamete, right? Which is this. And this parent can probably just give you one particular gamete, which is also just one that looks like this. So then even though you can do a 2x2 Punnett square, you don't need to, right? Because you know that you are limited by the number of possible gametes. So all you have to do is cross this gamete with this gamete, and this is what you get. Okay, so you know that the offspring is going to be heterozygous. Okay, for it's still going to be brown eyes because that's the dominant, and it's still going to be red eyes because that's the dominant, right? So you're going to get 100% brown body, brown body, red eyes, but you're going to get a heterozygous condition. Okay? So what if now I ask you to cross, let's see, what if I ask you to cross two heterozygous brown body, red eyes? So you're crossing this, and you're crossing it with another one that looks like it. Now you're crossing two heterozygous brown body, red eyes. So now this Punnett square is going to look a little different, right? Because you can have different possible gametes here. You can have this possible gamete or this possible gamete, or well, I guess this one's going to be the same here, but this possible gamete and this possible gamete. So then when you do your Punnett square, right, now your Punnett square is going to be a little bigger here. So you're going to put one parent. Let me see if I did this right. Oh, sorry, I didn't do this one right, because this one's this. No, never mind. I did that right. Just double check here. Okay, so this one's right. So what if I'm crossing? Okay, yeah, I'm doing it right. All right. So then you could do this and this, and then you could do this and this, right? And then this is what you're going to end up with. All right, so then you're going to end up with some recombinants here that do not look like the parent. This is a recombinant. This one is not a recombinant. This one is not a recombinant. And then this one's a recombinant. Okay, so you're going to end up with some recombinants here. This is a recombinant, and this is a recombinant. Oops, where did it go? And then you're going to end up with some that are not recombinant. Okay. All right, let's do another one. What if you're crossing? What if you're crossing this? So here you're also crossing, let's say, two heterozygotes, okay? And let's remember what the wild type was. This is the wild type. So this is wild type, and it's normal, and it's brown, red eyes. Okay, so nothing here is wild type. Here you're crossing two heterozygotes. Okay, so what are you going to get from this cross? So you have this here, this here, then this one is here, there. And then you're going to end up with, and I got to write smaller here, this, okay, homozygous. And then you're going to end up with this and this. And that is going to be like this parent. And then you're going to end up with this and this. And that's going to be like a parent. And then you're going to end up with this and this. And this is going to be a recombinant. Okay, so here you have a recombinant here, a recombinant here. But if you just want to count how many wild types you have, let's see. You have, this is wild type. This is wild type. And this is wild type. Now, the reason why these two here are wild type, because remember that brown is dominant and red is dominant. So the fact that you have this genotype here and this genotype here make it wild type. And then here, this recombinant, it's actually going to be ebony scarlet. So you're going to end up with 1 ebony scarlet and 3 wild types. All right, let's do another one. What if you have a cross between a wild type and a scarlet brown? So brown body and scarlet eyes. So again, let me just write down the key here. So ebony body is this, brown body is this, scarlet eyes is this, and red eyes is that. So remember, the wild type is the dominant. So if we are saying that brown body and red eyes are dominant, over scarlet and ebony eyes, then the homozygous wild type is going to be, so anytime you have this and this, right, you are wild type because you have these dominant traits. So what if you are crossing a homozygous wild type like this with a scarlet brown? So that means the only way you can get a scarlet brown is scarlet would be, actually brown would be here, and scarlet here, and brown here, scarlet here. So let's say I'm crossing a homozygous wild type with a homozygous scarlet brown. What would you get? So you can do the 2x2 Punnett Square again, right? Or you can just say, well, this will give me 1 possible gamete, and this will give me 1 possible gamete. So then 100% of my population will look like this. So 100% of my population is going to be wild type. Because remember, wild type means that you have these two dominant alleles, and you do. You have it here and here. So 100% of the population is going to be wild type. All right, so these are just a few practice problems, including linked genes.